All right, so what we have here is another landscaper special. This one got brought to us. The wall is falling apart. The door wouldn't shut right, so the customer finally decided he needs to bring it over. But what's going on down here is where the main frame tube meets the beaver tail frame member, it's broken. All the frame members broke. The welds are broken up in here, which caused this whole tail to start sagging, which broke all the welds in the corner over here, tore that all apart, which broke the wall free. The whole corner is just free now. Also the wheel box failure. We've talked about this before. Wheel box failure is 99% of enclosed trailer failures, but the poor construction on this one didn't help. So all the outriggers are failing. This one's broke off, this one's broke off. As we walk down the trailer, this one here is broken. These are all bending down and cracked. The whole box is collapsing from the frame. So what's happening is the main frame is where the axle rides and the box hangs over here. These outriggers are important. This is what holds the shell up to the main frame. And when these outriggers aren't tied in properly, then the box is trying to push down as the frame is trying to push up. Another thing you'll notice right here, as we've talked about this before, is our axle clearances again. The axles, you'll see here, bottoming out on the frame. It's the wrong equalizer and the combination of the wrong hanger and equalizer. So therefore you see we got it lifted by the tire right now, and it's pushed it all the way up where the spring's bottoming out on the frame. If you have the proper equalizer, that won't happen. This will straighten out and it'll stop it from coming all the way up. It gives you your axle travel here. So because it's the wrong equalizer, the wrong hanger, the spring's hitting the frame here and the axle's bottoming out on the frame there, which is gonna cause them bent axles. If we make our way up to the front, you'll see here, this whole tongue is only held in by 16 gauge material. This is a 16 gauge crossbar piece of sheet metal that's barely welded on this side. You'll see here, there's no welds where the tube meets this tube. No welds here. They just depend on this weld. They put a 16 gauge piece of angle iron in here that they welded this side, and then a little 16 gauge piece of plate here. So what you'll see is the tongue goes all the way out here, and there's nothing tying the main frame to the tongue other than this piece of sheet metal. And you'll see right here that because the tongue's pushing up, it's trying to compress this piece of metal. This is bowed up right here. This is buckling in, and it's all because there's not proper framing in here. They're depending on this piece of sheet metal, which is what we addressed on our last project. One of the things we adjusted on the last project. It looks like this whole front corner is actually breaking and falling out as well. You see the gap here. This should be all the way up against there because this is a wall stud. That's what's holding the walls up. If you look over here, they just have this one little piece of tubing coming out to here that's pretty much doing nothing. So the wall's trying to push down on the main frames, and all this stuff is just sagging out. They shot it through here, didn't tie it to a cross member. They put a small cross member here, which has zero structural integrity. So this has the same problems, inherent problems, as the other box trailers that we've been working on. Most all 8-foot trailers that aren't built properly all have the same problems. All these outriggers are bent, broken. You see right here, this one's completely cracked, broken off. This is the second one. The wheel box hanger is actually missing. And then if you look here, as we go down the trailer, you can see better on this side. This is cracked, broken, cracked, broken, cracked, broken, cracked, broken. So this entire wall is collapsing. The only reason why the front, this one's cracked and broken too, but the only reason why the front's being held is because it's on the lift right now. So that tube is keeping my front end in line while I work on the back end. Another thing you notice, if you come around over here, is the crossbars are lined up with the wall studs, which is a good thing on this trailer. The bad thing is they put the outriggers in backwards. So this outrigger should be in line with this cross member, which should be attached to this wall stud, so that this wall stud is supported all the way across side to side on the trailer. And that's what also keeps the boxes from collapsing. But they completely missed the outriggers and the studs. So now the whole force, the whole load of the walls is on this little 16 gauge piece of angle iron right here, which is also failing, and it's cracking the outriggers. This is the most common problem. This is why I preach that Wheel box failures are 99% problems of trailers. This is just another example of why it happens. All right, to completely wrap around to the other side, this is the good side. Your splice between your tube and your bent piece of sheet metal to go into your beaver tails, held on by a little piece of 16 gauge sheet metal. The welds on the inside are cracking and broken. On the other side, they're completely broke all the way through. You'll see here, outriggers are failed. The splice here, where they tried to tie the wall in together, is broken. Same thing on the other side. Terrible space to splice it, or you got to plate it over or something. And this wall too is also collapsing, and all the outriggers are cracked and broken. So we're gonna have to figure out, again, you're not aligned. You have the floor cross tube that's lined up with the wall stud, but the outrigger's in the wrong place, so the load's not being transferred all the way through. So we're gonna go ahead and add some cross members, or add some outriggers into that line up with these cross members, jack the walls back up, get everything straightened out. So what you see as well too is this back piece is just sheet metal here. So it's been dragged, pulled out. This side got dragged so hard that they ripped it off. So what we do to fix this is we cut this off. The problem being is our door hinges are attached to that piece of sheet metal. So when you start tearing this apart and peeling this back, it affects the performance of the door. So what we do is we cut this lip off here, add a piece of tubing, squeeze it back together, and then stitch weld it all the way down. And then we have to do another piece of tubing out here to act as an outrigger, because all the load from this back corner is being transferred through this little piece of sheet metal right here, and they're just not strong enough. All right, so the original complaint was the customer was having a hard time keeping cables, both cables on the door. So obviously it's only pulling on one side. And the reason for that is when this frame member collapsed, it threw the door off. And then it broke this corner. You can see this corner again better up here. It broke that, busted that corner out, which is the main support for the box as well. So you have a combination of bad outriggers and your mainframe support is broken as well. In that process, it broke the corner, the upper corners too. It broke this one, and it peeled the whole top jam back. So therefore now the spring is hanging all crooked. The cables are crooked. There's a couple shops that tried to fix it. This one's breaking out as well. So, but there's no support from the bottom to even tie the top into. So we have to support the bottom, jack the floor back up, get our posts back to where they need to be, square the box back up, and then take all this apart and gusset the frame back out to tie all that back in together. So then we can reset the cables and keep the door straight. But we have to straighten our frame first before we can get to anything. We took this apart just to see how bad it wasn't tied in, but we have to start from the bottom and work our way up. To do a quick overview on what we did back here, we went ahead and plated the outside of the frame, boxed the inside of the frame in. We added tubed outriggers here. We re-welded all these broken outriggers out here, pulled the wall back in, welded the wall to the outriggers. We added a 2x4 crossbar here with a piece of angle to catch the beaver tail plywood. Another 2x4 piece of steel here. We added a 2x2 quarter wall. It's actually a 2x3 quarter wall here to support this whole back end, straighten it all back out. I put some little skid blocks in there. Maybe you'll hit those instead of tearing up the trailer again. And then we just mirrored the same thing on the other side. All this stuff was broken over here as well. So we re-welded the outriggers, plated, boxed in the end of the tube. That secured the beaver tail bracket from falling off again. Did a tube outrigger here, and now we're just gonna paint it up and start working on the front. All right, here's our new suspension kit installed. It's got the heavier shackles, the taller equalizer. You can see our axle distance is much further now. And this is what I was talking about. This is a simulation just as we had it before, pushing up on this front axle. And you can see this front axle, this back axle gets locked out and it won't let this one travel up anymore. So now we don't have that problem of the spring coming up, hitting the frame and the axle bottoming out on the frame. So it'll compress a little bit more from here under load, but at least with this setup here, you're gonna break a leaf spring before you bend an axle. If you bottom out on the frame, you lose all your suspension. But right here, if you overload one axle, you'll break a leaf spring and you'll have an indication first. When you're bottoming out on the frame, you have no indication, you're gonna bend the axle. So that's why we put a lot of these kits on. With this kit, we do the crossbars here because these heavier shackles transfer a lot of energy back up into the frame. So we crossbar the front, the back, and the middle, all three, as per manufacturer's spec. If anybody were to ever read what the hangers call for from the manufacturers, they want them crossbarred. So this is all the manufacturer's spec now, as it should have been from the beginning. So one of the repairs I do on these 1/8" frames, because they can't handle the load of the outriggers, so I went ahead and 3/16 plated the frame from the hanger, which is where the energy comes from the ground, and carried it into the second cross member, tied it into this cross member here and the outrigger. So the load coming from the outrigger transferred through the plate, and the load coming up from the hanger will also transfer the plate, and then it gets equalized on each side with the crossbar. So this stiffens it up a great deal, just that little addition right there. So you notice also with this suspension setup in comparison to the other one, the equalizers would rock too far one way or the other way, and it would take the shackles and flip it upside down and get stuck. That'll never happen. You still have your angles for your spring travel. They're still in the proper position, and it's never going to get, even if you transition, it's never going to get flipped or stuck the other way. Review on this, we went ahead and built them an extension flap out of all aluminum. After adding the studs, we put some new plywood on there. The old plywood was no good. Did some weather stripping around there. We welded up the back jam, added some support on the inside. A couple things you'll notice that when you test out a trailer, if you push on the walls, the whole trailer should rock all together. You shouldn't have where the top rocks and the bottom. If the bottom is stable and the top is rocking, you have a failure in the wall someplace. Another thing to look at is if you get in the back corner of a trailer and you jump on an enclosed trailer, you jump up and down, the wheel boxes stay straight. As you're jumping, the wheel boxes will stay straight. You'll hear the roof flexing up and down. If you find that the wheel boxes are flexing in and out like this, then you have a problem with the outriggers and the walls are falling apart, which is one of the things we notice on this one. But when you jump on them, they should stay straight. You can look at them as you're jumping. It doesn't take a whole lot, but if the wheel boxes flex in and out, then you know you have wall issues, you have outrigger issues. So another thing we did is we made them a little block right here instead of doing another flap extension. This will help from, as he's bringing the mowers in and out, from beating up the edge of the plywood, beating up the edge of the door. And it's a little more comfortable ride getting in and out. It'll get beat down and wore out a little bit, but it'll settle down. That pretty much wraps up how we got this one done.